you could buy a used car for the price of a humanoid robot. A decade ago, that was completely true. The cheapest research-grade biped ran well over $1 million. Today, that same cash buys a Tesla. So what actually changed, and what does it mean for the rest of us? The short answer is simple. Everything flipped between 2023 and 2026. Humanoid robots went from lab curiosities worth billions to products you can actually budget for. Entry-level models start in the low thousands, thanks to streamlined manufacturing. Commercial-grade units run from the tens of thousands to well over 100,000 depending on their specs. Soon, everyday shoppers will walk right into a store and buy one. We will break down what drives those prices and how these machines actually work. You will finally know when you can grab one. The humanoid robot market splits into 3 clear tiers. The gaps between them tell you exactly what you are paying for. Entry-level models run from $6,000 to $20,000. Chinese manufacturers dominate this space by tapping their domestic supply chains. The Unitree R1 lands at roughly $6,000. It is the most affordable bipedal humanoid on the market. The Unitree G1 costs about $16,000 and delivers noticeably better dexterity and sensor arrays. It remains the most frequently recommended model for serious automation projects. It walks, carries objects, and handles simple manipulation. Businesses are testing humanoid concepts now. Several warehouse operators across China's Yangtze River Delta have already deployed the G1 units. These robots handle light material movement on the floor today. Tesla's Optimus targets the $20,000 to $30,000 range for commercial buyers. The company plans to hit that number by pulling directly from its own battery and actuator supply lines. Figure AI's latest bot lands in the $30,000 to $50,000 bracket. That is a massive 90% price drop compared to their earlier test models. The market is now flooded with mid-range options priced between $20,000 and $50,000. Builders got there by launching a full design for manufacturing overhaul in partnership with BMW. Figure AI's latest bot has already clocked over 60 hours of non-stop warehouse work. It runs completely on its own without human intervention. Boston Dynamics' electric Atlas robot commands a $100,000 to $150,000 price tag. Buyers pay that premium because it features unmatched mobility and the sharpest manipulation tools on the market. Apptronic Apollo and Agility Digit cost $50,000 to $80,000, but you will mainly rent them through robots as a service plans. Enterprise models run from $50,000 to over $150,000 and pack advanced capabilities plus heavy support infrastructure. You secure them through service agreements instead of buying them outright. Those headline figures only tell half the story. What actually drives the real cost is a whole different story. Picture a humanoid robot as a mechanical body built from actual parts. Every single system carries its own price tag. Hobby 2 tours. And motors alone swallow 30% to 40% of the total budget. A humanoid needs 20 to 40 actuators functioning as electric muscles depending on its degrees of freedom. Custom actuator designs from companies like Figure AI cost $200 to $800 each. Chinese manufacturers drove actuator costs down by 50% through domestic production. That shift is the single biggest reason. Off-the-shelf servo motors from suppliers like Maxon or TQ Robotics cost $500 to $2,000 each. Unitree still hits its price points. Compute and sensors account for 15% to 25% of the overall budget. Onboard, compute typically relies on an NVIDIA Jetson-class chip or custom system on a chip. These processors handle the heavy lifting for perception and planning models. Add LiDAR depth cameras, force torque sensors, and IMUs to the frame. That sensor suite adds $2,000 to $8,000 to the build, depending on quality and redundancy. Big players like Tesla spread those compute costs across their entire automotive division. That financial trick is exactly why their per-unit numbers look so aggressive. Battery systems claim 10% to 15% of the total cost. Humanoids need 1 to 3 kilowatt-hour packs that deliver 2 to 8 hours of runtime. Battery costs have already dropped to $100 per kilowatt-hour in 2026. They started at $140 in 2024 and keep falling every single year. Software and AI carry the invisible cost. That is where real differentiation lives and where costs are hardest to pin down. Figure AI and Tesla have spent hundreds of millions of dollars on foundation models that actually steer robots. That research spreads across every single unit but builds the intellectual property that separates a capable robot from an expensive mannequin. You will never spot software on a price tag. It is the entire reason the robot does anything useful. Prices are dropping approximately 40% per year in real terms. That slide comes from bigger factories, tighter supply chains, and relentless learning. The advantages compound with every unit built. If that trajectory holds, the mid-range consumer price point is just a few years away. The secret is not any single component, it is the entire stack working together. A humanoid robot runs on 3 distinct layers. Each one advances at its own pace. The hardware sits at the very bottom. It provides the skeleton and muscles called actuators. It also houses sensory organs like cameras, LiDAR, and force sensors. This is the part you can actually see. It also accounts for most of the bill. The middle layer runs the show as the control system, where algorithms translate high-level goals into coordinated motor commands. Walking is surprisingly tough because it is essentially a controlled fall that never actually lands. Modern humanoids use model predictive control and reinforcement learning to stay upright on uneven surfaces. The top layer handles physical AI through foundation models that read your intent and plot the exact steps to execute it. An NVIDIA robotics executive recently said, "The world still lacks a ChatGPT equivalent for a robot." The analogy is perfectly apt because digital smarts do not automatically grant physical mastery. This is the layer where demo videos crash into real-world performance. Language models completely transformed text generation. A matching breakthrough in physical AI will transform every single thing a humanoid can do. Other robots need custom spaces. Humanoids are built for human environments. Stairs and door handles and narrow corridors and kitchen counters. Every single one is designed around human proportions. A humanoid does not need a factory rebuilt to accommodate it. It just walks in and starts working. The shift is already here. The initial production wave is underway. 1X Technologies unveiled the Neo back in the early 2020s. This home-ready humanoid has already secured tens of thousands of deposits. Buyers are paying a solid mid-tier price to lock in their spot. The first batch will roll off the West Coast line in the coming months. Will Depew used to work at OpenAI in San Francisco. A June 2026 New Yorker profile quoted him saying his own house placed 3 orders on humanoid robots. The target crowd spans the Bay Area, Los Angeles, and New York. This feels exactly like the new iPhone. One researcher put it perfectly. The exact same robot that nails a backflip might fail on a simple flight of stairs. And that reality is exactly why home deployment raises so many questions. The catch is that nobody knows what these machines can actually do at scale. They face entirely new safety hurdles that industrial environments never had to worry about. The gap between lab tricks and real-world reliability remains huge. Optronics CEO Jeff Cardenas puts it plainly, around small pets and children there is still serious work to be done. Commercial deployment is already here. Tesla is actively rolling Optimus units into their own facilities right now. Figure robots are already logging over 60 hours of fully autonomous warehouse operations. Boston Dynamics sells Atlas strictly to big companies that can actually afford the premium price. That gap between a flawless lab demo and a real Tuesday at 7 a.m. warehouse shift is shrinking fast. It will never replace your vacuum, but it will act as a flashy early adopter toy. It will occasionally amaze you and occasionally embarrass you completely. Here is the realistic timeline where you can actually order a humanoid today and get it delivered before the year ends. Full household capability is still 3 to 5 years out. The industrial shift is already happening right now. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day, and tap the video on screen to keep going. See you in the next one.